All right, people, Lac Operon. The Lac Operon is the quintessential example of how prokaryotes regulate transcription. You're not transcribing things all the time, you're only doing it when you need it. So in prokaryotes, we've studied this specific thing, the Lac Operon. And the Lac Operon, an operon is made up of, it is DNA that is made up of not just the structural genes, which you see there in yellow. The structural genes are the genes that are going to be transcribed, but they're also made of two other pieces of DNA, which are right next to it. There in a light blue, perhaps turquoise, is the operator, and next to that is the promoter. So we have these three different sections of DNA that collectively are the entire piece that we're going to refer to as the Lac Operon. And it's about regulating when can those structural genes be transcribed. Now, a couple more things to know before we start getting into the action. In peach, is that salmon? I'm making a repressor protein. Typically, they just call it a repressor molecule. I feel like it's a little more pointed to call it a protein. It is supposed to bond to the operator. So look at it sit there and bond to the operator. And when it does bond to the operator, it blocks the promoter. The promoter has half of the repressor in the way. Well, the promoter is supposed to be where the RNA polymerase attaches to the DNA. That's the only place RNA polymerases can attach is at the promoters. So here comes Mr. RNA polymerase, and he's trying to get to the promoter. He can't do it. He tries. Stupid repressors in the way. I mean, look, this guy's working hard. He's trying and he's trying. He's getting close. Nope. Can't get there. Well, this makes RNA polymerase mad. I mean sad. Yeah, sad. Sad's better. Now, what is RNA polymerase to do? He needs something that will get that repressor protein to fall off. He needs something that's going to induce that repressor protein to fall off. And that's going to be lactose, hence the name Lac Operon. Now, lactose, a disaccharide sugar made up of two monosaccharides. Milk sugar. Come on, people. If the lactose shows up in the cell, the lactose is able to bond to the repressor. When he bonds to the repressor, watch this. He's going to do it. Yeah. When he does, the repressor protein falls off. Unfortunately, the stupid word promoter came with it. That's not supposed to happen, but you know what? I'm going to fix that in a second. Boink! See? Piece of cake. Now that the repressor protein changed shape, couldn't attach to the DNA at the promoter operator site, now RNA polymerase, he's going to be able to attach to the promoter. He attaches to the promoter. He moves 3 to 5. You know it, people. Directionality. He moves 3 to 5, reading that strand, gets to the structural genes, and he do what the RNA polymerase do. Transcription, baby. So he makes a piece of RNA. That RNA is then going to go through translation. You all know what translation makes. It makes protein. Ta-da! The protein that the Lac Operon structural genes makes is lactase. Lactase, the enzyme that breaks down lactose. So the whole point to this is to regulate when you're going to make the enzyme that can break down lactose. Why would you want to break lactose down? Because that lactose is going to get broken down, turned into glucose so that the cell has energy. This is only going to happen if the cell's out of glucose, by the way. An advanced thing we don't really have to focus on. Because believe me, there's more to this. So as those different lactoses get digested by the lactases, eventually the repressor protein doesn't have a lactose attached to it. Its shape reverts, and it goes back to the operator. This might sound familiar to regulating enzymes. There's some parallels there. Now, the RNA polymerase wasn't just sitting there on the structural genes. He was reattaching to the promoter over and over again, transcribing over and over again. Plus there's millions of those RNA polymerases, but to keep it simple, I drew one, and I left them sit there. Now that the repressor protein is attached, poor old RNA polymerase, sad again, because he can't attach, and now transcription's not happening anymore. Regulating transcription, there you go.